Alright guys, just me in the shop today, so I'm going to try and get a little bit of work done on the bike. I am going to attempt to 3D scan the engine and the frame of the dirt bike so that I can pull the engine and frame into Fusion 360 and try and put the engine inside the dirt bike frame in CAD so I can figure out where I need to cut the frame of the dirt bike before I actually start cutting in real life, because you can only cut once. So let's talk and we're getting to it. Part number one, I think I'm gonna try and scan this second. I wanna see how well the scan does. Here we go. Front tire feels flat, that's fine. Back tire seems to be holding air, that's nice. Plastics are up too. Fix that some other time. All right, just gotta do it. So, here is what I'm working with. This is a Xbox 360 Kinect, and this is actually my Xbox 360 Kinect from, it might actually be my brother's, because it was his Xbox at first. But this was a 3D infrared camera used by Microsoft and Xbox to do stuff similar to like what you do with the Wii. A lot of like body movement video games. Unfortunately, these things never really caught on because they just weren't amazing at that. Plus the Wii was already more popular, so that segment was already kind of filled. But lucky for us, come on, how do I delete this? Lucky for us, they make really good 3D scanners, and not actually really good. Like if you spend, I don't know, $1,000, I'm sure you can get something a lot better. And then they make 3D scanners, of course, that cost like $30,000. I've actually got to touch some of those before, like $100,000 3D scanners, and they're absurd. But for what I'm doing, just building an engine in SolidWorks, building the dirt bike frame in SolidWorks, and just seeing what conflicts with what, this is all I need. I don't need it to be the best 3D scanner out there. Yes, that looks a little better. All right, so the software that I'm using is a free software made by Microsoft. There is one other software available for this out there. The name is blanking on me for the moment. And unfortunately, it works pretty darn well, but it is a paid software and it's like $150, and I'm just not willing to do that right now just to play around with this idea. But as you can see, there is part of the bike. Let's see if we can get the whole thing. There we go, that's looking a little better. All right, I think I need to get a little closer. Oh yeah, look at that. Don't worry, I'll get a close up in a little bit. This looks awesome. Here I am 3D scanning the bike yet again, just to get you a better view. Look at this thing. That'll do it. All right, scan number 1 is done. Now I need to scan the actual engine. So let's get to it. And that is all. That's not true. That's not all at all. I'm now going to clean up here, head back home, plug my laptop in, and start pulling everything into Fusion 360 and see where the engine needs to be inside the frame for everything to line up. And then I'll get a really good idea of what I need to cut and what metal I can save. So let's get to it. Hey guys, I'm finally back, done working on the computer. Took me quite a while to actually get anything usable out of those scans, but I think I got something. I'll show you here real quick. Look at this. Mike and Santino in the shop right now. Let's see. There he is. All right, but yeah, so quick rundown about the 3D scanning. The scans were actually such high detail that my computer struggled incredibly to use them. Anytime I tried to move one of the scans around, it would take my computer like 5 minutes before you'd actually see the scan move. That, coupled with a couple of issues related to 3D scanning, made this incredibly difficult to actually get anything useful. So one giant issue that I ran into is usually when you're building something in any kind of CAD software like SolidWorks or Fusion, you start at the origin, XYZ000, right at the center point, and then you build out of that, and everything is in this coordinate system around that 000. Unfortunately, when I 3D scanned the frame and the engine, I was holding the 3D scanner at like a weird angle, and it placed the actual scan at a weird angle off center axis. And so having the scans be so high detail that it took like 2 minutes before you would see them move, and having them be incredibly off axis so they wouldn't move the way you wanted, made it near impossible to work on. But I found some workarounds. I probably spent like 8 hours of my life working on this, and I'll show you guys right now. All right, here's the actual scans. These are full resolution, which was a huge pain to get to work on my computer, but so worth it, because look at how beautiful this thing is. You can see exactly what this thing is gonna look like. Like, there it is, Gixxer 600 engine inside of a KTM frame. So here's left view. Take a look from the top. You can see that engine is giant. It juts out of either side of the frame by quite a bit. And let me see if I can get you guys a view. Here you go. So here is, let me try and rotate it actually. All right, so now you can see the pink is the subframe of the dirt bike, or not subframe, the frame of the dirt bike, and this is the engine that's being swapped into it. And you can actually see right here that the engine is so large that it engulfs the frame. So that's clearly where I'm gonna need to cut the whole front of the frame. Up here as well, I'm gonna need to cut a significant portion of the frame. There's some more view over here. So let's see. right here, there's a bar that goes through and then the frame goes down. That bar is gonna be cut off. The frame is gonna be cut right about here. This whole belly portion of the bike is gonna be removed. It's gonna be cut right there as well. All of this will be welded back. I am debating how I'm going to weld that back in. I actually think what I'm going to do is I'm going to use the engine as a stressed member of the frame. The original Gixxer 600 used the engine as a stressed member, which means there's no cradle frame in front of it. Instead, the frame bolts on right here and right here. And then the engine is part of the frame holding the bike together. That is most likely the way I'm going to go, and then I am going to build a belly pan to protect the engine from rocks. One unfortunate thing though, you can see right here, the oil pan extends really low. That's kind of a bummer. I think I lost like 4 inches of ground clearance, but that's just something I've got to live with. And over here, you can see here's where the swing arm mounts. This little portion, I am worried about hitting the engine against the frame in a couple of locations. It's really hard for me to tell from this scan what is the rope that's holding the engine up and what is the actual engine. So some of these parts I'm just gonna have to kind of see once I start cutting. But luckily, I've got a really good idea of where I need to cut so that I don't cut off too much material. And there it is, waiting for me. All right, I'm gonna get to it.